All right, boys, happy Monday. We're back. We're going to be learning 3-3 today, Systems of Inequalities. We already learned that a system of equations, or a system of any sort, is two or more equations, or in this case, inequalities together on one graph. And when we were solving equations, we're looking for one exact intersection point. We could find the solution to a system of equations by graphing, substituting, or elimination. When we're dealing with inequalities, we can unfortunately only solve it by graphing. I only say unfortunately because it's just a little bit more work, but it's easy. In order to solve systems of linear inequalities, simply graph and shade each inequality individually. The area of the system which has overlapping solution sets are the solutions of the system of inequalities. Sometimes it's called the solution boundary. So you're going to graph each, you're going to shade each individually. The area where both shadings come together, that's the solution. I'm going to shade in a very particular way. I do this on purpose, and you're going to see why I do it. I think it makes things easier. Some people use different color highlighters. Some people use different color pencils. I'm going to show you how to do it with just one color, and it's pretty easy. Okay, first things first. As always, whenever we're graphing, we got to solve for y, okay? So let's just call this guy 1 and this guy 2. So let's solve for 1 first, and y is going to be greater than negative x plus 4. I just subtracted the x on both sides. Let's focus on one equation at a time, please, gentlemen. Y-intercept here is 4. 1, 2, 3, 4. My slope is negative 1 over 1, so down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, backwards, up 1 over 1, up 1 over 1. It's greater than, so is that going to be a dashed or solid line, gentlemen? Dash, that's going to be a dashed line. All right, let's go ahead and make this fancy here then. Okay, it's going to be a dashed line. Okay. Of course, it's a little bit off, but okay. So that's my dashed line. Now, let's shade it. It's greater, so is it above or below, gentlemen? Above. Just two straight lines like this, gentlemen. Trust me, you'll see why. Now let's go ahead and figure out number 2. Okay, I could graph this with y-intercepts, can't I? X and y-intercepts, can't I? Or I could solve for y, but we're talented, so when x is 0, the y-intercept is 3. So let's go ahead. Let's just do it in red so you can see. Different. And when y is 0, x is 7. 7. Okay? Now that is going to be a solid or dashed line? Solid. Solid line. And am I going to be shading above or below? It's less than, and there's no negative in front of the y, so above or below. Okay, now watch. Check it out. Going below, and then right here. See where you have that cross hatch? Right here. This is where the blues were. See where the blue and red intersect here? And this little area right here? You see that? That's the solution. Where the blue and red combine, where the shadings overlapped. So this little section that I have outlined, that little area right here in green, and it keeps going on forever, expanding, expanding. This whole entire region or boundary will be the solutions. And you can choose any point in that boundary and it will be a solution. I'll prove that right now. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. Okay. If I'm right, 9, negative 3 better work with either one of these equations. Let's prove it. When y is negative 3 plus 9, is that greater than 4? Yes. Okay, over here. 27 minus 21, is that less than or equal to 21? Yes. Does this make sense, gentlemen? Pretty easy, right? If you know how to graph an inequality, you could do this. May I continue? Thank you, gentlemen. Whoa, wrong way. Hey. All right, sorry about that. All right, same thing. Let's get right to it. We'll do number 1 in red. So I've got negative y is greater than or equal to negative 2x minus 3. But I'm going to divide by a negative. Please remember that when you divide by a negative, what happens to the inequality? Yes, good job. 2x plus 3. Now let's graph this bad boy. Y-intercept is 3. Slope is up 2 over 1 to the right. Up 2 over 1 to the right. Please remember you always run to the right unless going backwards. Down 2, 1 to the left. Going backwards, down 2. This is going to be a solid line. Am I going to shade above or below? Below. It's y is less than, so I shade below the graph. Does that make sense, guys? Hello? Okay, good. Now, we'll do number 2 in blue. It's already set up for us. Y-intercept is 1. My slope is down 1 over 2. So down 1 over 1, 2. Down 1 over 1, 2. Down 1 over 1, 2. Let's go backwards. Up 1 over 1, 2. And that is a greater than or equal to. So it is going to be solid. And I'm going to shade above. Bam. Why didn't I bother shading this part? Exactly. Could I have done all of this? Yes, guys, but I'm just used to it already. And I know that this region right here, I don't have to do that part. I don't have to do that part because that's not going to give me the solution. Now, if you did it like that, am I going to be mad? No, of course not. Of course not. But now, just definitely be able to ascertain your solution. Your solution area is this right here, right? Everything in this. So you would do an arrow, and you would say those are my solutions. Does that make sense, guys? You got to be really neat here, okay? You do not need 2 colors, but you definitely got to be neat, okay? Definitely got to be neat. Wherever you see the checkerboard, that's your solution. Yes, sir. Yes, sir. That's what I'm saying. On the test, on the homework, you're going to see your area that's all checkered here. In this case, is this region here, right? This region right here. And you're going to do an arrow. You're going to say that region is the solutions. The whole entire region. Because it would be impossible for me to list all the possible solutions here. It's infinite. You'll never end. Does that make sense? Okay, I'm going to take that silence as a yes. All right, now, your favorite, word problems. Your city's cultural center is sponsoring a concert to raise at least $30,000 for a city's youth services. Tickets are $20 for balcony seats and $30 for orchestra seats. If the center has 500 orchestra seats, excuse me, how many of each seat must they sell? Okay, labels, 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 labels. Talking about 2 different seats here, right? We're talking about orchestra and balcony. I'm just going to, for giggles, say that X equals balcony and Y equals orchestra. Doesn't matter if I change that up. I don't care. As long as I define the variables. Okay? So now, I know that it's $20 for each balcony and $30 for each orchestra. And I want to make at least $30,000. So how would I set up that first equation, gentlemen? Yes, sir? No. No, you know, I don't want to be rude, but no. Think about that, my man. You're saying that X plus Y, first of all, it's not equals. It's at least. So it has to be greater than or equal to, but look, you did not assign any values to your balcony seats or your orchestra seats. It's $20 for every orchestra seat. That's a tongue twister. Plus $30 for every orchestra seat. $20 for the balcony, plus $30 for each orchestra, to have a total of $30,000. Do you guys see this? Now, here's the trick. This is what makes this hard. They say if the center has 500 orchestra seats, how many of each seat must they sell? Okay. The center has 500 orchestra seats. How can I represent that? Orchestra seats. Very good. So why, okay, they can sell less than or equal to 500 seats. That's what they've got. Now from here, gentlemen, unfortunately, I can't use my tricks of elimination or substitution. I have to actually graph this. So let me show you how to graph something large scale like this. Let me go ahead and move this over here for a second. It's no different than any other graph, except you're going to have to use some intervals. All right? That's all. First of all, let's use the x and y intercepts to graph our first equation, which I'm going to underline here in blue. What would my x-intercept be here when y is 0? When y is 0, guys, what would x be? Guys, when y is 0, what would x be? Not 150. 1,500. Guys, what happened? Do you guys not see that? Or you all of a sudden forgot how to find the x and y intercepts? Guys, talk to me. Hello? Okay, no one's talking. So 20x plus 30 times 0 has to be less than 30,000. So when you divide by 20, guys, do you see that x has to be 1,500? Do you see that now, guys? Okay, are we awake today? Hello? Hey, let me say hello, Mr. Morrow. Okay, are you with me? Okay, thank you. Guys, this is an honors class. I'm not here to waste time, please. Don't make me waste time on simple mathematics again, please. So the x-intercept is going to be 1,500. What's the y-intercept going to be, gentlemen? When x is 0. 1,000. Thank you. Okay. So now these are pretty big numbers. So what intervals do you think would be wise to go by? 500. Yeah, why not? So I'm going to go 500, 1,000, 1,500, and then over here 500, 1,000, etc., etc., etc. Okay. So I've got too big. We know that they're by 500s, okay? So my x-intercept here, 5, 10, 1,500. My y-intercept here, boom. And I'm right here. Can I go into the negative sides? No, I cannot go into the negative sides. Now, y is less, oh wait, we forgot the shade. Go above or below? It's greater than and there's no negative, so I go above. So it's going to be any of this up here. Now, y is less than 500, less than or equal to 500. So here's 500. Y is less than or equal to 500. So down here. Yes, it would not go into the negative, yes. Thank you, son. So it'd really be from here. And it's all of this. Down in there. And that will be your solution set. This part right here. Does that make sense, gentlemen? You promise? Okay. Let's do one more. A pizza parlor charges $1 for each vegetable topping and $2 for each meat topping. You want at least 5 toppings on your pizza. You have $10 to spend on toppings. How many of each type of topping can you get on your pizza? All right, I'm going to say that x equals the $1 topping, and I'm going to say that y equals the $2 topping. I really don't care what you call them. as long as you label them correctly, gentlemen. I want at least 5 toppings, so some of the dollar toppings plus some of the $2 toppings to have a total of 5 toppings. And I can only spend $1 for every topping plus $2 for every meat topping to give me a total of $10. Does that make sense here? So I'm going to go ahead and wait. During the toppings, you want at least. How about I learn how to read? At least. So greater than or equal to. Sorry, my reading skills were off. And you have, so you have 10, so this has to be less than or equal to 10. Okay, duh. Okay, sorry about that, my brothers. So let's go ahead and solve this. We've got y is greater than or equal to negative x plus 5. And we've got y is less than or equal to negative x over 2 plus 5. You see that, how I got those guys? Okay, I'm going to assume that silence is good today because I'm not going to pull your teeth. Equation 1, y is greater than or equal to negative x plus 5. 1, 2, 3, 4, 5. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Boom, done. And that's greater than or equal to. And then I've got y is less than or equal to negative x over 2 plus 5. 1, 2, 3, 4, 5. Down 1 over 1, 2. 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 And that's going to be solid as well, but it's less than. So it's in this little boundary right here. Solution. Does that make sense, boys? Promise? Yes? All right. Awesome. We are golden then, guys. Thank you for a great lesson. God bless you. Have a great day.